Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Designing support for collaborative search around a tabletop. So to begin with, just a few words about me. I was studying information engineering in Constance at the university for the bachelor and master's degree, and I finished in December 2006, and since then I've been a PhD student and research and also teaching assistant. It's quite closely coupled in Germany, those two things, since December 2006, and my research interest basically has always been around those two topics, so designing empirical studies and conceptual interaction design. And I've been involved in research already during my bachelor time, and I've been involved into quite different domains of, for example, visual information seeking systems, obviously multi-touch and multi-display environments. And since I'm from Germany, also automotive research is quite common to get money from them. So that's also been a topic in a few projects. So let's start with the first topic. The concept maps method as a tool to evaluate the usability of APIs. So that's a project we've been working on for about 2 years now, and we will present it at CHI this year. And I work together with a few of my co-authors, who probably some of you might also know, because Hans Christian Jetter was also here in Cambridge with me last year. So I would like to give him some credits here too. So the idea is basically when we're looking at the programming world as it is today, an API can be basically found everywhere. So APIs are very predominant, and thereby APIs also have quite an impact on product usability and also whether developers are happy and can produce good products. So Joshua Bloch put it that way, that good APIs increase the pleasure and productivity of the developers and the quality of the software they produce. So if an API is such an important aspect of a product usability, one would assume that it's quite important that the API itself also is usable to a well extent in terms that the developer can actually make use of it. So then the question arises, well, how can we evaluate the usability of an API? And basically, to tell you the truth here is that we didn't approach the topic in terms of, okay, let's search for an interesting research area. The thing was that we were developing a framework for zoomable user interfaces for multi-display environments by ourselves, and came to the same problem. So at one point we wanted to know whether this framework and the API to the framework is actually usable, and whether we can deploy this as open source, for example, or whether nobody will make anything out of it. So this was the reason why we were dealing in the first place with this question. And then we came across that actually there's not that much research going on here. So when we're looking at existing approaches, they look quite familiar from an HCI perspective. So you have lab-based usability testing also for APIs, in terms that you get developers in for an hour, asking them to do some programming tasks. And in the end, you, for example, measure task completion time, or measure lines of codes, or look at the lines of code and try to identify where problems appeared or not. And you have field studies with observation and interviews, which obviously are quite extensive, and expert evaluation methods, which try to use experts to analyze whether an API is usable or not. And from our perspective, what was missing here is some more generic view on this whole topic, or some more abstract view, so to say. So, because if we are looking at a developer using an API, that's often what we see. So we're not seeing that much actually of the interaction with the API. So it's different to using a graphical user interface, where you can actually tell whether someone understands, for example, the navigation structure or the interaction concept of the graphical user interface. It's much more going on in the head. And we had the impression that the existing methods didn't really try to figure out what's going on in the head. So they try to more focus on the results, what people do with the API, and we try to assess in a way, well, what's going on in the head of a developer. during the time. So our approach is to use a concept mapping technique to actually visualize how a developer sees the API. So basically, we are asking participants or developers to illustrate how a system or prototype one is developing working by and how it interacts with the API. So to visualize the interaction in some kind of concept map and to get a better picture out of it instead of this thing which already looks a bit cluttered, I show you a small video which illustrates how this works. So the idea to start with, the video material and some example results I present here are from a case study we did with the framework I just mentioned about zoomable user interfaces. And we did it here with students in a programming course where they had to learn how to use this framework, and we did it in pair programming style. So we asked two of them to work on a project together and also come into our lab to work on the concept map then together. And basically what we asked them is then to go ahead and try to represent in this kind of map style how their prototype, which is represented by those green cards, interacts with the API, which is represented by the yellow cards. And we, as I'm going to present you later on in detail, the yellow cards were defined by us. So we predefined what kind of concepts of the API were interesting to us, and we handed them over to them, and they had to decide which of the concepts they knew, which were familiar to them, and how they interacted with their prototype. And as you can see, it's quite an iterative process, so it's not just hanging things in there and then you're finished. So they had to discuss a lot and had to think about how to link things together. And we also asked them to actually, as you can see here, to mark things and to describe how the interaction between the API concepts and the prototype worked. And in the end, of such a session, we also asked them to rate how they felt about those concepts of the API. And we did this by giving them different adjectives, pairs of adjectives, positive and negative ones, and asked them to just pin them on such a concept as you can see here, and thereby say, for example, that it's a complicated concept, or that's an easy to use concept or convenient concept. And we were interested to see whether they chose a more positive or negative adjective here. So as you can imagine, it's the concept is quite an important aspect here. So what is a concept? Basically, we didn't want to define it in such a close way because it really depends on your API and what you're studying. So what we're suggesting here is that a concept can basically be anything from a certain procedure to a class name to a more abstract level of putting several things of an API together. So for example, if you're interested in studying how an interaction modalities are accessed over the API, you might want to define this more in more detail with several concepts. And on the other hand, if you're not that interested here, you can abstract and just put one concept in there for this part. But you can also think about whether it's a good idea to actually give your participants concepts or let them define the concepts by themselves. And we also tried it out in an earlier study. And from our experience, if you, there's the advantage if you let them define it by themselves, that it's really more what they think about an API, so you don't introduce a bias. On the other hand, it's a bit more problematic than to compare among different users how they see the API. If everyone defines his or her own concepts, then you basically have only individual maps you can look at, but you can't really compare them between different users. And the most important aspect, which was already present in the title, is that it's a longitudinal design. So the idea is that participants don't create just one map, but basically they come, in this case, they came into a lab for 4 weeks each week, and in each week, we gave them the map they had created the week before and asked them to basically update this map to represent their current understanding of the API. And this is important as such because thereby we were able to visualize changes over time without explicitly asking for changes. So we didn't have to ask them, how has your understanding of an API changed? Because that's probably a very difficult question to answer. But by giving them the artifact and saying, so that's what you created last week, now tell us how you would see it this week and what we would change, you really have this quite explicit visualization of what's changing over time, and whether that's over a week or over days, it really depends only on how much time your users spend on using the API, so whether you expect a development in their understanding from day to day or from week to week. Since it were students, we didn't expect them to be that quick, so we did it over the weeks. So the key contributions of the method basically are that you have an elicitation of how the API users see the API, a visualization of what's going on in their head. Still, as I said in our example, we use pairs of programmers, and thereby you could argue whether it's really elicitation or more a kind of construction as they're discussing it. And we're not really sure whether the way they are displaying it in the concept map is the way it really existed before the session in their head, or whether that's part of the construction process in the session. So that's a question we would have to address in future research. What's also interesting is that you can basically also ask the developers of an API, so the owners more or less of the API, to create such a map as well, and then see how it differs between their understanding of their own API and the one the users get from using it, and thereby allows you to actually assess the gap between the different understandings here and see whether what the API developers want to communicate with the API actually transfers to the user or not. And those two aspects then allow you, I'll give you a few examples in the following, to identify misconceptions of the API architecture and the structure, so what things in the API people don't understand. And the method also allows you to see such problems with, although the participants may, or the users may actually have come to a working prototype, so they might have made it work at some point, but still due to the method you are able to identify whether they have actually understood what they were working on. And with the map expansion design, you basically have the chance to differentiate better between learnability and usability to see whether things persist or disappear, whether problems persist or disappear, and allows you to understand whether that's perhaps an issue more of learnability, which might disappear over time. So to give you a few examples, it's always a bit difficult with examples here because I can't give you a full introduction to the concrete framework we are evaluating here. So I hope it's possible for you to understand. So one example finding is what we call API affordance, based on how Stephen Clark called it, is related to the input abstraction. So I'm zooming in here now to one part. Basically, the API allows users here to use different input modalities, such, for example, as mouse, but also OSC commands for touch input or gesture input, and to control your prototype with these different input modalities. In the task we gave our participants here, they were only asked to integrate a mouse input, and what the API offers is this kind of abstraction here, what we call a landscape handler, which basically abstracts the input modalities from the view, which is on the bottom here. And as you can see in this example, and that was present in most of our groups we tested here, they didn't include this landscape handler. So while they still made the mouse input work, and for all groups the mouse input was working, they didn't really understand that there was an abstraction layer in between. So basically what we assume here is that they probably copied some code to make it work at some point, made some trial and error tests, but here we can see that they actually, if they did now get the task to include, for example, touch input, it might cause problems as they didn't understand the abstraction as presented here. And I have a second video to illustrate a bit what I said with making changes visible. So what you can see here is how this group we saw in the beginning in the first video starts the second week with modifying the map. And it's really not only about the artifact you get in the end, but also watching this process of how they are changing, how they're discussing it. So when you're looking here is you really see how they're erasing out stuff and placing things in different areas. And by watching them and hearing them talk about it, you get a much better understanding of why their understanding of the API has changed and what exactly has changed. So it's really not only about looking at the final map, so to say, but also looking at the process. And what you could see here in the end is that we asked them at the end of sessions to mark these problem areas, so areas which they found really problematic, where they had issues and couldn't get along. And this also allowed us to see how these problem areas evolved over time, because we then asked in the next week, is this problem area still one, or has it changed, and whether they want to delete it or not. Yeah.
Model changes from week to week a lot. Is that an argument for a good usability or bad usability? Because if they're consistent from week to week, then you could argue that it's quite usable because they get it the first time round.
No, it depends whether the changes they make are extensions to their understanding, or whether the changes they make are because things were wrong in the beginning. So. In that case, I mean, if you're working with an API, it's not like you're reading a documentation in the beginning and then you're starting to work on it. It's basically you're working on the task and continuing there. And so it really depends whether you just discovered a new functionality of the API and extend your map to that extent, or whether you have to rearrange stuff or make corrections to the linking between the maps. So you have to look closely. It's not just... Change is not just good or bad.
I have two questions. One is when you are picking the participants, have you done any assessment of their training and the starting point? And second, I was curious, just what Alf was saying, in order to evaluate this, somebody has to know APIs. So should I assume that you or other examiners actually knew APIs quite well?
Yeah. Yes. So. To the first question regarding whether they knew of the experience level, so all of them didn't know the API before the study, so it was completely new to them. But still, since it's set up on the .NET framework, they were a bit familiar, so we asked them how much familiar, but a moderate from 1 to 5 scale, it was about 2. How familiar they were with the .NET framework. So that obviously also helps in, So if you're doing that in a study, it's definitely an issue to understand what are people knowing beforehand and what after. Because what we also saw is that people, for example, we had one participant who hadn't any experience with .NET, but with different programming languages, more with C++, and he had quite different problems than the other groups, because he had just a completely different understanding and wiring of his brain, how things should work, and thereby had different problems. And that's obviously something you have to keep in mind when you then trying to find out what to change for your API to make it more usable. Yes. So regarding this slide, what I wanted to show here is that even if you or to actually to start with, you don't have to watch all the video from the beginning. You can basically start with a more descriptive way of analyzing things. So here we have simply put it's for one group over the 4 weeks. We have all the different concepts we provided them, and the different adjectives. So a red one is a negative one and a green one is a positive one. Those are the problem areas. Black means this concept hasn't been used in that week. So basically you get quite a compact view of how things change over time. And even here you can, for example, see that the few and the few model, which belong to the MVVM pattern we applied in the framework, it caused some problem during this first week, but was then regarded as precise and convenient in the second week. So that's definitely, for example, a situation where you should then look closely into the data and see what the reason here might be, whether it's just that they got some new help, which was, for example, the case here, that they asked for help after the first week and then got some new information and understood how it worked, or whether this is some other kind of learning. And you also see, for example, here the DB server issue, which was rated negatively during the whole time, but was part of a problem area during 2 weeks. And even in the last week, it wasn't considered a problem anymore, but it was still considered confusing. So you could tell that, well, even if they made it work, it's still not the best way to do, probably. And one final issue is that if you, when you were looking at the maps, you see lots of clutter, obviously, of the physical artifact in terms of how people write on the map, and sometimes it's really difficult to actually see how things change over time. So what we did here is we used a graph visualization tool, which was also developed in Konstanz, and used it to represent the maps in a digital way. And this was quite easy because the basic structure of the concept maps are nodes and links, and so it's really a one-way transfer to a digital way. And by using then graph analysis tools, you're able to, for example, what I'm going to show you here, to visually compare the map of a group with the map the developers have done. And how that works is shortly illustrated here. So here you had the master map, and here you have the map of the group. And the problem now is that even if they might be semantically quite similar, they might look completely different. So it's just from the layout how they did it. And what we can do here is that we take this master map of the API developers as a reference, and then lay out the other map so that concepts that are in the same or similar place are moved around. And by that, it allows us to basically get a much better impression whether those two maps are similar or not. And what we can also do is here now use an animation tool to basically play back the animation between the two. And now we see, for example, concepts disappearing and others appearing between the two maps, and can then assess whether these differences are problematic or not. So for example, what we could see here was that what you could see here is that it's difficult to see on the screen, but we used an attached behavior pattern to attach certain behaviors to objects, such as whether an object is draggable or rotatable. And this group in particular did include these behaviors, but didn't include them in the map. And so that's also a misconception whether they really understood how this concept worked, or how this underlying conceptual model here worked. Yeah.
So how did you? I'm just curious how do you input information about the maps into this tool? Like the one was created by the developer, but you had to map what you saw on a whiteboard into this. So how did you code it?
Yeah, it's basically just a manual way of doing it. So you have graph editors like YEd, for example, and you can basically just place nodes and links, and that's what we did. So we had the physical artifact as the the one we wanted to replace as a digital, and so we just remodeled it digitally. So obviously then the position is not 100% exact, but that's not of importance here for the analysis part. Yeah. Okay, so still there are obviously things to improve. So for example, what we see is that people are really hesitant in making big changes if they just want to introduce one new concept. For example, regarding space, if you have a cluttered area and you want to include a new concept there, people mostly put it on the other side and then draw a long line over the whole board, which then makes obviously the analysis difficult and also makes it difficult for the participants in the continuation of the process to understand their own map. So what we could try here is to use a combination of an analog and digital representation, for example, with ÜNOTO technology, so that people can still create the maps in a physical way with paper, but we have a digital representation on the fly and can make changes to the digital representation, which should make this much easier. Another issue is we could also try to integrate similarity algorithms to quantify the difference between maps. The difficulty here obviously is how to assess what is similar or not similar. So we haven't really thought in detail about that, because it's really an issue where you would have to make lots of studies to find out what's similar and what not. And two aspects which I already mentioned, whether pairs of programmers, whether that's elicitation or construction, and also the pre-given concept versus self-defined concepts are issues one could explore in more detail. So overall, this is what it's important from our perspective is that's really a flexible method, not in terms only of how you apply it, but also what kind of analysis you can do with it. So it's not just one way to analyze it, so you can look at your data from quite different angles, and that I think allows you to get a much deeper understanding of what's going on. And especially obviously the longitudinal design to allow you the tracking of changes, and as we use the hands-on materials to actually allow this method to be applied not only in research but also in companies who are actually developing APIs so that they could test them. And from use cases, so we could basically, as I presented, to make an API more usable also, but to derive or improve guidelines for API design. Okay, so this was the first part. We already had some questions, but probably it's a good idea to make a quick stop so that you can ask further questions if you have them before I continue with the next topic. Yeah.
I was just wondering if you thought you'd find out different things if you got the people to start from scratch rather than remind them what they did last time?
So we didn't test it in terms that we. Do you mean whether we would ask them in the second week to start from scratch again?
Yeah, with a blank canvas.
Yeah. I already also got a comment from my co-advisor. We haven't explored that, but it's an interesting issue. I mean, basically, the problem you're introducing here is that you might get very different maps then from the first week to the second week, just because people don't actually know what they did in the first week. And so it might introduce a bias into your interpretation of changes, because it's not the changes of the understanding, it's more or less the changes how people represent things in a second time. So I would say that if you ask the people to create this concept map 3 times the same concept map on 3 different days, you probably would get 3 different maps, since it's not just an elicitation but more or less also a construction approach. It's really a mixture of both. Yeah, but it's still it would be interesting. Yeah. Okay, then let's move to the next one. So the next one is also a paper we will present at CHI, and it's something we did, Hans Christian, Michael and myself, when we were in Cambridge last year. So Natasha was also quite helpful with input, and we got some input from Sharam and Ottmar Hilliges, and Gabriela also gave some feedback here. So you can now look whether we incorporated your feedback quite well or not. And probably some of you might also know it because we had it here last summer, standing in the entry area here. Basically, the idea is to bring collaborative search to a tabletop. So this is not a completely new topic. There are other systems that trying to do that. First, a short motivation why we should actually do that. So if you look, for example, at the framework of the mechanics of collaboration as Goodwin and Greenberg defined it, if you're having a tabletop, you probably could greatly support these mechanics of collaboration, as some parts of it are quite implicit in terms of, for example, monitoring that you have a workspace awareness, or that you have a more equitable working style. You have a closer face-to-face collaboration. So there are quite some aspects that at least have the potential to improve such thing as a collaborative search on a tabletop. What hasn't been explored before, and what we were focusing on in our design, which you can see on the bottom right as a sneak, were the idea of using hybrid surfaces and faceted search. So hybrid surfaces as the idea as introduced by Kirk et al. To use the combination of multi-touch interaction and tangible interface elements, the tangible interface elements that really merge into a multi-touch surface environment, and thereby allow a new kind of interaction, new styles of interaction, with the reactable being probably one of the most popular examples here. And we wanted to elaborate and find out how you could actually design such a hybrid surface for a search system. And so what kinds of compromises you would have to make, how to map the physical interaction on the search process, how to map the virtual interaction. And the faceted search approach we found interesting because faceted search is quite popular when you look in the web and websites like Amazon or so. So for product search, it's really a popular approach, but has been underrepresented in research for multi-touch search systems. So the idea is basically to iteratively filter an information space and come down to a small set which you want to explore, instead of populating a result set based on keywords. And we found it interesting also from the idea that you have the Microsoft Surface as a product or a computer which can be placed in flagship stores, and as a prominent thing that attracts people. And so we thought something like product search could be a real benefit to such a system. So basically the idea or the scenario we developed here was that we said, okay, let's assume we have a family of, for example, here 4 people, and this family wants to go on a vacation together. So they have to pick a hotel which fits all their needs, which is probably a quite difficult task because they all have different needs. So someone wants to have a hotel close to the beach, another one probably wants to have a great gym, so it's a sports guy, and another one wants to have excellent food to enjoy it. And the father says, well, €50 per night maximum, otherwise we can't fit it into the family budget. And if you look at this from a faceted search approach, it's basically a combination of Boolean AND statements, and it's relatively simple. The problem is that you might get to the point where you have 0 results because things just don't add up to another. So they might exclude each other from the things. So what then starts is a negotiation process from people trying to say, well, okay, if I'm not having my beach, a pool would be fine too, and I could cook myself. Okay, we can try to sneak in a bit more money, or hiking is nice too. And what you can see here then is that such a statement gets obviously quickly much more complex and makes it more difficult also from an interaction perspective to match that to an interface where you can then modify this and interact with that. And the problem might be that now we might have 150 results and we're not really sure whether we're happy or not, because basically that doesn't really help us. So what we have here is that it's really an iterative exploration with negotiation and decision making. So it's not just searching and then having an answer. So it's a real complex process. And it also involves personal as well as group work. And so that was also an aspect of we wanted to support in our design, that people are able to seamlessly switch between personal and group work to be able to fit this kind of style into their decision-making process. And the approach we took here is that we adapted the the filter flow metaphor, which was first introduced, I think, by Young and Schneiderman already in 1993, with the idea to make it more tangible and thereby visualize the search process as a whole. So not just having a list of arguments or what you're searching for and then having a result set, but basically visualizing how you get to this process and being able to manipulate every step in between. And from there on, we derived some research questions in terms of we wanted to see whether facet streams, for example, leads to a more fun and social experience, especially with increased group awareness, and also whether we could support the different search strategies and collaboration styles that might exist. And a last point, there are quite a few papers about whether Boolean logic works or not, and the conclusion more or less is that it doesn't work for the end user if he's exposed to it directly. So we were wondering if the way we packaged it into our visualization, whether that would allow people to actually understand the Boolean logic without even knowing that it is Boolean logic. So again, a short video. I have to find my mouse, which illustrates the use of the system. So here we have our scenario of, in this case, 3 friends who want to find a hotel together. And they're using here the classic approach with the catalog, which doesn't work because they all have such different ideas. And what you can see here is an information space populated by hotels. And now one of the participants here, or of the users here, places a token on the screen. And by placing the token on the screen, you get an additional layer, which then allows you to stream data above it. So we can see it here more in detail. So each token basically represents one search facet you can choose. And you have different labels here which you can touch and allow you to here decide for different facets. For example, we are interested in the price. And then an outer label which allows you to define categories for your price. So for example, we can say it should be between 18 and 150 euros. And then by touching this part here, you get a stream which then should stream the whole data over the table so that others can interact with it and you can combine a complex query with it. And what you can see here is that this works perfectly well in parallel. So someone can start here by selecting a personal criteria. For example, some features one wants to have. A bar is nice and a pool is also nice. And then stream those hotels matching these criteria directly to another token and thereby merging them to a Boolean-like AND combination. And what you... Sorry, wait a second, I stop it.
How come the images, the set isn't changing as you do
it isn't changing because since you have multiple users, you might have multiple not connected streams to each other. And the idea is that the background is not changing as long as someone doesn't directly interact with the background. So we have different possibilities here. So for example, what you saw at the beginning, if you're touching the stream, then you get a direct feedback in terms of which hotels are matching in the background. But if you're not doing that, so if you have several people having independent streams, you wouldn't actually know what you should display in the background because you wouldn't just merge all the research search queries in a Boolean-like end, because that wouldn't be what.
Okay, so as soon as you connect them up, it starts to change.
And not as soon as you connect them up, you have a special different token, which you will see in a minute here. And what you can see here is what was really important for us is that we also incorporate a Boolean like and or combination. So if you're placing two tokens together and directing the stream directly on a token, they are merged with a Boolean like AND. But if you're directing a stream directly onto another stream, they are flowing together and thereby representing a Boolean like OR, so a merging of this set of hotels, which is also represented to the user by the thickness of the stream then. And you have immediate updates all the time. So if you're changing here something criteria, then the thickness of the stream in the end is also updated automatically. So you get an immediate impression of what you're doing, whether that has an effect on the outcome in the end, for example, or not. And you can easily manipulate the whole interface. So it's what we call here a low viscosity of the interface, that it's really possible to, for example, lift the token up and not destroy the network by that, but preserve the basic structure, which you can see here, so that the outlets are then directly connected and you can place it back in and you get to the point where you've been before. So thereby making it really easy for the for the users to not be afraid to change the way they are interacting with it. And what you're seeing here now is the special token. I'm afraid it's so dark, but it's a blue token with a different shape, which allows you to access the results in the background and filter the data set in the results. So depending on where you place this token on your network, you're getting the results. And the idea here is that So one problem of faceted search approaches often is that you have a hard time of getting intermediate results from a previous step. So you basically often have to go all the way back until you made this decision and then change your decision. And here you can basically place the result token wherever you want and get the results from that point, and then also create a different stream direction from that point and explore the results in a different way. And we also use this token then for an explicit mode switching, so that you can then look at the results in detail and elaborate what you want to use, what hotel you want to choose. And that's also a part which is, where there's lots to improve, and we know that because, we also have some ideas how to improve, and I'll show you in a minute. So we did a couple of studies to investigate whether this actually works or not. And the first study was meant to compare the interaction as a whole, the interaction process and the collaboration process, to a standard web-based interface where people might know from the web, which allows them to click categories here and thereby filter the information space, and they had to do this together with one mouse and keyboard, so they had to decide on how to interact here. And what is important here is that we used a between subjects design, so we didn't expose our participants to both of those interfaces, but only to one, because otherwise we would assume that just because of the novelty of that interface compared to that, we might introduce a positive bias, so to say, for the facet streams. And one issue here is, so here's again the web interface a little bit bigger. One issue here is obviously how to actually evaluate that. So we were thinking about the common stuff like task completion time or so, but in the end we thought, as I said in the beginning, one important aspect, or the most important aspect really, is whether people are able to use this as a kind of compromise tool to make negotiations and to switch seamlessly between the interaction styles. So we decided to use a task which is a bit more uncommon, but worked quite well for us. So to simulate this compromise and negotiation process, we created a situation where people would have to make negotiations in the lab. And if you just ask them to search for things they might like and ask them to agree on something, it really depends on the group you have, whether there's someone who doesn't want to make compromises or not, and whether they might have all the same interests. So we control this by creating characters for all of our participants, which basically told them what kind of preferences they should have and what kind of ideas or what kind of hotels they should like. And the idea here was that if they try to find a hotel that matched all these criteria, they wouldn't find one. So this would lead to a zero-hit problem, and thereby making them or forcing them to actually starting negotiation about what kind of aspects they should reduce, and thereby we could then see how they proceeded there. And from the results, so we analyzed first the quality of the compromises, and we did that by calculating some kind of measure for the difference between the optimal compromise and the one they chose. So an optimal compromise can be calculated mathematically by just finding the optimal solution from all the different sets we provided them, and then we calculated how much they how far away they were from that part. And what you can see here is between the web interface and the facet streams that the differences are quite small, and they are also statistically not significant. So basically we concluded here that we reached a similar quality of negotiation here, although the Facet Streams interface as something quite new is, it's not usual for people to reach the same quality of work here at once. Still, one could also argue that the measure is not sensible enough for the research question here. So that's also something one could look in a further study to find here a different approach. But what's really interesting overall are the search strategies we discovered. So, for example, what you can see here in the video, it's a bit speeded up to is how one group started creating a search. And what you can see here is really that they started out individually and moving things around all the time. So it's really that you don't place a token and then continue, but you're constantly moving and switching and seeing whether it fits with from the space you're having and connecting it. And even if they had some sometimes you see that they had to open up one of the wheels you saw several times to select something. It didn't really hinder them in their overall interaction process. And what you can see here then is that two of them are finished, and they're now waiting for the third person to also finish. And then they decide to, they're seeing, okay, now she's finished too. She's waiting for the other to finish to put everything together and then elaborate, okay, where do we have to make negotiations because we don't have any results here. And they're doing this together here. Another thing we often saw was that people were helping each other. So I'm going to quickly stop that here. What you saw here is that this person over here has already finished his three categories he had to define, and sees that the other person has real problems doing this, and quickly comes over and starts helping. And this was overall very interesting in terms that people sometimes even recognized that someone, for example, wanted to look at the results and grab the result token for some other person and placed it on the right position just because they were closer without any talking at all. So the awareness was definitely on a really high level in terms of how to interact with the interface. And the last thing, what we also saw quite a few times is here, when they had those different streams, they elaborated in pairs what to do. So for example, they took those three and those three together and then saw, okay, we have 0 hits, so let's take these three and these three and do this in a really systematic way. So not just putting everything together and then seeing, okay, so now everybody has to reduce something, but to systematically try to find out where's the problem.
One question. I noticed, are these 3 female participants?
Yes.
Have control for the gender?
No, we didn't control for the gender in the groups. That's basically, we would like to have that. It's just very difficult to get that if you want to have 3 in a group and 72 participants. So in the end, we weren't able to control that. So what we overall saw, for example, for the individual query formulation is that most started with such a personal style of query formulation where people started individually and then at some point combined their search. However, we had quite varying query connection strategies. So as you saw, this systematic pairwise thing, or just a pairwise when 2 were already finished, so they were connecting them and not waiting for the third to arrive, or what you saw in the beginning, that really the whole group waited for everybody to finish and then connect things and then go on. And that leads us to the next step, so how to refine. And we had quite a few groups who took a democratic approach, so to say. So basically they said, okay, now everybody looks for some category to loosen up, to soften. So not really systematic, trying to find out what's the problem, but saying, okay, everybody has to change something and then it's fair. Or they were looking as a group really at the network and trying to squeeze out. And mostly there was one dominant person who tried to manage that by providing the insight how the network should work or is working. And we had many changes back and forth between tightly coupled and loosely coupled. So even in these phases, it wasn't that people didn't change between. So it might start with a group analysis of the network, and then someone might switch over to his own personal 3 tokens and start making changes there without notifying the others, just switching back and forth between tightly and loosely coupled. And regarding the awareness, which I already mentioned, is really what people were really aware of which facets are in use, so where's something missing, whether we had quite a couple of times people forgot to select an actual value for their facets, so for example select a category, and often others recognized that and hinted towards that and said, well, you have to select here something. And also for the group and the individual preferences. So one of the most funny stories we had here was that we had a character for one person who wanted to have childcare, was supposed to have childcare because he had children. And at some point this participants abandoned the childcare feature, and another participant said, well, you can't do that, you have to think about your children. So that's something which also didn't happen in the web interface. So we compared that from the strategies, that people were much more aware of the individual criteria people had and were much more eager to try to match these preferences. And what I also showed in the video, the low-level support and parallelization of work. So I think I have to speed up a bit. So regarding the web interface, what we basically had here as an overall is that we had a lot of conversational noise in terms of that people were constantly talking to each other, asking, do we have already set this facet? Do we have already set this category? What's already defined? What's not defined? So it was a much less personal relation to the rows and to the different categories. It was more or less, we could have given them a list of categories they should apply, and they would still have come to the same more or less conclusion. But what we also saw, and what's probably also come up to your mind, is that in the web interface, people were able to seamlessly switch to the browsing much easier. So they basically started with selecting a few categories and then were able to already browse a few results and look at them in detail. While with facet streams, people really only did that in the end when they had a few results left, but not before that. So that's definitely an issue, how to improve a more direct access to results and allow people to do this. Okay, I'd like to briefly illustrate the second study we did, because it has quite an interesting task again to analyze that. For the second study, we were interested to analyze whether people really get the Boolean logic we included here. And for this, we used individual participants, so no group sessions, to actually also exclude the mutual support here. And what we did is that we presented them with a network on the surface table. And on this network, we marked this in time. So we marked first this position here. And we gave them a hotel on a printed card and asked them whether this hotel was in this stream at that part of the network. And they had to answer yes or no. And we said whether that's right or wrong without explaining why it is right or wrong. So basically what you would also encounter when you do that in the real world, you would recognize whether you're right or wrong and then try to do this. And so we had different difficulty levels here. So for example, for that you have to understand that here's an OR connection, so it basically is enough if this or this part is satisfied by your hotel or by the categories here, or this is completely unrelated to this whole stuff here, whether this has to take into account the whole network basically. So we did this for 3 networks with 3 hotels per network with 4 spots per hotel. So each participant had 36 questions to answer. And we were really happy to see these results, as we had quite a good succession rate here. So in total, nearly 93% of answers were correct. And but still, what you can see is that AND connections are much easier to understand than the OR connections. So that's still an issue, and we're also thinking about how to actually improve that even more, that people understand that if 2 streams flow together, then that's a logical OR. I'll skip a bit the conclusion because that's all the stuff I already said, and give you a few impressions on what to improve. So we had the impression, I think that's always if you have a good interaction design and a good way or how you did things, I think you can recognize this, one, by that it works in a user study, 2, people like it when you present it and when you show it, and 3, everybody comes up with lots of ideas how to improve it. And that's actually what happened here. So from the user study, but also from basically everyone we showed it, everyone came up with ideas what we could do and what we should do, and it's a long list. And just to mention a few, so the access and awareness of results. So we are currently exploring this a bit with multi-display environments to add additional displays to cope with that. Another idea would be to get more results at your fingertips. So basically, that was an idea of you, Natasha. When you put your finger on a stream, you would get a preview of the results at that point directly in front of you, and you could, for example, flip through them or select individual results and thereby put them through the pipeline. Then the visual representation, you could improve the flow metaphor, for example, also with colors, so that you know which user created which part of the network, and an animation of the flow that you actually know that here hotels are flowing, and which is not that obvious if you look at it for the first time. We were thinking about integration of keyword search to make it map to other domains also. And there's also the question of scalability, so how to integrate more complex faceted information spaces, especially if it's difficult to represent that in categories. So as you saw in our data, we were able to put everything into categories, and if you can't do that, you probably need other interaction styles or widgets to make that accessible, which could make it more complex. And also to integrate this whole process of, as search is just one part, so what you're actually doing in the end. Can you save your results, for example, on one token, or can you take it home with you and do other things? And there are quite a lot more of them, which I can't go into detail to all of them. So those are the references I used in the presentation. The others are in the papers, and that's basically all from me, and thanks for your attention.
Thank you. Any questions? Do you have any questions about the second part? Okay, very good. So thank you very much, Jens.